Hey guys, welcome back to How It's Explained. My name is David, and today we're going to be going over another algorithm question from LeetCode. I haven't posted in a while, and I apologize for that. I will try to upload more often, more consistently, but I've just been busy with work these past few months, getting projects finished and all, and so I'm back at it now. Hopefully, I'll be back at it for at least a good amount of time. And I think that when I do these algorithm videos, what I'm going to do is less of, I know I used to always explain it, go over strategy, go over the code, walk through it, and then do a walkthrough of the code again with an example. I think I'm going to cut that last part out because kind of, walking through the code once for us software engineers, I feel like we do understand it. And me verbally walking through the code with an example is not as valuable in these videos as it is to just run it. Of course, in an interview situation, you are going to have to walk through the example or your code with an example. So go ahead and do that. Don't think that it's not part of the process, but I think as far as these videos go, um, people gain more from the first few parts, and so I'm going to cut off the last few parts off and see what the reactions are. But anyways, here is an easy question from LeetCode called Buddy Strings. Given two strings A and B of lowercase letters, return true if and only if we can swap two letters in A so that the result equals B. And so first off here, we're going to be swapping two letters in A, and we're going to try to have it equal B. When I first read it, I was kind of confused. I was like, okay, what does a swap mean? Because if you look in these examples, it doesn't explain what a swap is. It just has the input and the output. And so I thought, okay, are we swapping from A into B? But I read it more clearly. I read it again, and it was clear actually that we're swapping within A. So either we're going to switch to A and the B here and have it equal to the B A here, or we're going to swap here, and we're going to have to do a swap, which is why a case like this is false. Now, before we go deeper into this question, I do want to reemphasize the importance of edge cases. And me, admittedly, having not done algorithm questions in quite a bit, I jumped into this one because I thought I had the solution, and that's the what is it? That's the trap of easy questions that a lot of us get into, especially in an interview situation where you know that the highest stake is getting the problem right. And so when you immediately think, okay, I have the solution in my head, I'm going to look good if I bust it out right now and get it right. But the downfall of that is if you don't, and there are a bunch of edge cases that you missed, that then you look like the guy who doesn't really put importance on edge cases, which are very important actually. And so if you don't think edge cases are important, you might want to stop the video and try this question out because you'll be surprised that this was an edge case trapper, for me at least, for sure. I thought that I had the main, well, I did have the main algorithm in my head when I ran it. I'll show you my submissions. I have a bunch of wrong answers. These are all the wrong answers that I had to go through before I actually started getting the right answers. And we're gonna go over my algorithm very fast, and then we're gonna look at the better ones because mine, although it works, and although the speed isn't too bad, the 76 was the best answer on the results, and mine was at best 80, which is not too far off, but definitely. I looked at the other I looked at the other solutions, and they were cleaner too. So we're gonna go ahead and do that. A couple things that other than going through edge cases you want to do is what are the regular cases, like if we're going to have a equal to b, and this is now going into the strategy. If a is going to have to equal b, well, first of all, the length needs to be the same, and then we're going to have to do one swap, right? So what is that? That means that the length is going to have to at least be a 2, because if it's a single letter, then you can't swap, and so that's an automatic false. Of course, the empty string, that's an automatic false. Um, and then another thing is that all the letters are going to have to be the same, because if all the letters are different, no matter how many times you swap them, they're not gonna. It's not gonna matter. You also can't do a simple sorting of the letters because at that point you don't know if they all had the, what is it? if there was only one swap that happened or not. And so that's another thing that you have to count. The main part of the algorithm right now is what was in the question. We can only do one swap, and so that's the trap that I got caught into. I thought, okay, I know how to count the swaps, and so let's go ahead and start writing it. Let's go ahead and start testing it. And I didn't even think about the edge cases. Let's go into the code. And so, see, the first thing that I wrote was strike. I knew that, okay, as I go through, I'm going to go through a for loop, which is down here actually in line 19. I'm going to go through A, and every time a letter does not equal the same letter, that's a strike. And at most, I can run into 2 encounters, which means that I'll be able to swap them. But at the same time, if I run into more, that means I would have had to swap more, and that's an automatic false. Which later in here, I said, okay, if anything's less than, or if it's less than or equal to 2, then this used to be a true, otherwise it's going to be a false. And this one actually should have been if it's equal to 2, because if and only if. So there's a bit of a mess up there too, but the code works. All right, so the first case here is grabbing that first obvious case. If A does not equal B in terms of length, then it's not going to work out. No matter how many times you swap letters in A, it's not going to equal B if it's not the same length. And also, if the length is less than 2, like I said, you cannot swap a single letter or an empty string. And so those were false cases. These ifs are edge cases, and I'm not going to go over all of them because I didn't go over all the edge cases anyways, but as you solve this question, you're going to run into the edge cases, especially if you have just the basics like I did. And a couple of them actually are down here. I wrote them down. Like empty strings, they weren't really edge cases, but these right here in particular, AA, when it was AB and BA and AB and AB, at what point do we start addressing those? And so I thought, okay, all these edge cases seem to be 2-letter words, and so I addressed it up here. In this, if the length is 2 conditional, and then when I got down here, I ran into another edge case where the strings were completely equal to each other, and so at that point I'm like, okay, I'm also going to have to count the letters and see that they are the same. And that's what this check letter does, is it checks to make sure that, let's see, it creates a map and it checks to see that I have the same letters in each of them, and also that here that I don't have any duplicate letters if the strings are equal. Yeah. Anyways, let's go ahead and, like I said, my algorithm this time around, it wasn't the cleanest. And what I did was actually, or you can do this too, as long as you have a working solution, once you submit it, you'll go to this page and you can see success and details. If you click details, you'll get to this page, which will look like this. And this is everybody's submission. And so what I did was I grabbed this guy's, because he seemed to have a really fast solution, and I copied and pasted it into mine just to make sure that it still works, because sometimes they update the question and someone with a really good runtime answered an older question, and so I plugged in his, and I guess maybe they added more tests or something, but the best I could get was 76 on his. Apparently when this guy submitted it, he got a 44, and so I guess maybe it also depends on your computer, I don't know. But let's go over his. It's really clean, so I like how he did it. If A is an empty string, return false. Good. That means we can't swap anything. If the lengths doesn't equal each other, return false. Good. No matter how many times you swap, these are the base cases. If A equals B, okay, so if A equals B, then return A dot length does not equal new set of A dot size. And so what this means is, okay, this is really checking within the word A, or within the word A, or the word A, sorry. are there letters that are going to be very uniquely, not unique, same? And so kind of if you have a.length and the string was ABC, the length is 3, and if you create a new set, it's going to be a set of A, B, and C values. If the word A was AAB, then the length would still be 3, but when you create a new set with that string, it'll be A and B. It only take the set is created with unique values, and so now this size is not going to equal that. And so if we're dealing with words that are completely equal to each other, that covers this last case that I fell victim to, ABCD and ABCD. Although they are equal, there is no swap that you can do because they're already equal, they're already perfect, and so you can't swap anything, you can't afford to swap anything. But if it perhaps was something like AAB V, BAVV, sorry, ABAV, then this would have worked because you could swap that. Or actually, no, this is not a good example. This is what I meant. If the words are equal to each other, then there has to be something that is the same letter, because here you can't afford to swap anything. Here you can afford to swap the A and the A, which will still equal this string. So that's why this one says, okay, as long as if the letters are equal, if the new set proves that there was a duplicate letter in the word, then we'll return true. And this statement is going to return true in that case. All right, so this person covered the base cases pretty well, including some edge cases. Now the rest of this is just really counting the amount of swaps that it takes once you're going into a word. I'm pretty sure this is what the count stands for. And so it looks like we're going through A, and as long as if A does not equal that character in B, then we're going to increase the count. And looks like this is probably some uh, edge case conditionals, and so let's skip that for now and say, okay, we counted all the times where the swap was needed. Is that true, if not false? Um, okay, so we're gonna go into this edge case now, where we are within the bounds of, okay, we are looking at a letter that does not equal each other, and so this first conditional, first of all, in a situation like this, would happen when B does not equal this A. And so, let's see. When this A of I, which is right here, this B, does not equal B of I, which would be this A, then we're going to increase the count. That's just for the basic, making sure we only do one swap. And we're going to say, okay, char A, if not char A. And so pretty much, is anything defined here yet? And if we look up here, it's been initialized but not defined. And so it's not defined yet. And so let's go here and mark what it is. Char A is going to be B, because A is equal to this, and B is equal to this. And so char A is equal to that. Char B is equal to an A. And I'm going to make that lowercase just for consistency. And so if you see what happened right there, char A was not defined at first, and so let's see, if not char A, that's why we go into here and we do define it. And so char A became this B, char B became this A. Okay, and so the magic hasn't happened yet. One wrong letter means just one wrong letter. If we only get one wrong letter, that means there is no swap to be done. And so then we're going to end up returning false based off of never increasing the count to 2. But imagine we do get to another letter. Great, we have an option, we have an opportunity to actually swap. And so what is going to let us know that this is a good opportunity to swap? Well, next time we run into a situation where it's not equal would be this next letter right here. see the last letter here is A, this last letter here is B, and with in one eye we can see right now that B and A needs to just be swapped and A and B needs to be swapped. But how do they know? Well, we recorded a B here and now we're saying, okay, can we put it into, can char A be in this position in string B? And so that's what this code does. Can char A be in this position of string B? And so pretty much if it doesn't equal that, that means it can't be. And likewise, if this isn't allowed that, then we return false. I guess if either one was wrong, then that means there's no perfect swap, and that's why we have to return false. Um, Hopefully that's clear to everybody. Char A here was defined as B, and we hold on to that value in a variable because we want to make sure, okay, if we end up swapping these two, would it be perfect? Can it be this B? And if it can, then yes, that's great. If it's not, then too bad. And if there are too many of these, we might even go into this statement multiple times, but ultimately every time we go into this outer if, we're increasing the count by one. And so if it did go in there too many times, perhaps it wouldn't have ever been caught by this, but it would have been caught by the count number. So yeah, I really like the way this person created their algorithm. I thought it was pretty clear. Very different also in the way you look at edge cases, because usually you look at the base cases or the base, you know, yeah, I guess you could call it base cases, where the algorithm will or should fail automatically. And then you also look at edge cases, and maybe sometimes, at least I'm used to putting those edge case conditionals at the top, but he incorporated it into the heart of his algorithm. And so I thought that was pretty good. He or she, this could be a girl. Um, And so I'll leave it at that. I thought this was a pretty good solution. Hopefully this video explaining it helped you out in case you were running with this question. But I think I would like to emphasize again that the most important part of this solution that I thought, or this encounter of this question, was get your edge cases. Get it in before you start writing the algorithm. And especially for me, I think if you in a situation where you're chasing after the edge cases as it's failing on you, you're gonna patch it into things like I did, like patch it into here. You're gonna patch it into a helper function. I feel like this person might have thought of some of these edge cases before, or at least refactored their code to make it look prettier uh, to address the edge cases. And so hopefully this video helped you out. I'm planning on trying to be more consistent, at least once a week and perhaps more. But I know that these are weird times for everybody, and so I hope that you'll be patient with me as you have. And if you did think that you found value in this video, go ahead and subscribe. I will upload more of these, and so I'll catch you in the next one. Bye.